In this video, we're going to explore the critical laws, regulations, standards, and practices that shape effective security governance in organizations. This information is important for understanding how to protect systems and data in real-world systems and environments. Effective security governance starts with clear policies that consider both internal and external factors. Internally, policies must align with business objectives, utilizing internal system data and allocating resources appropriately. For example, an organization might determine which employee roles need access to financial or customer account data. Externally, policies must comply with laws, regulations, and industry standards, which vary by location, industry type, and business purpose. For instance, the Sarbanes-Oxley Act, or SOX, regulates financial data for U.S. public companies, while the California Consumer Privacy Act, or CCPA, protects the privacy of California residents and applies to companies with California customers. Another key law, for example, is HIPAA, which establishes strict standards to maintain patient privacy for any system processing or storing patient data. Organizations operating in Italy, Greece, or Spain, or anywhere in the EU, must also follow the GDPR, which provides EU residents with transparency and control over their personal data. Noncompliance with these laws can lead to fines, sanctions, losses of license, or contractual losses. Compliance can be monitored internally or by third parties, often using automation control applications to ensure consistency. Due diligence involves a process of setting controls to maintain compliance, while due care focuses on implementing, maintaining, and responding to those controls. An executive signs official documentation to confirm the organization meets compliance requirements. Now let's look at the General Data Protection Regulation, or GDPR, in detail. Organizations handling EU residents' personal information must comply with the GDPR or face fines up to $20 million for violations. The GDPR mandates limited storage transparency as well as legitimate collection of personal information. This provides EU residents with 8 privacy rights, which are as follows. First, the right to be informed about when their data is being collected. Second, the right to knowing why their data is being taken, as well as who is taking it. Third, the right of access to a copy of their data. Fourth, the right to rectification or correction of inaccurate data. Fifth, the right to be forgotten or removed within 30 days unless needed for legal or health records. Sixth, the right to restrict unlawful or unauthorized processing of their data. Seventh, the right to data portability, which means the ability to move data to their desired location. And eighth, the right to object to data being pulled or collected. The payment card industry includes financial institutions and organizations that process payment cards like debit cards, credit cards, or prepaid cards. The PCI security standard is a coalition of stakeholders that develops standards designed to secure payment card accounts and transactions. Their key standards include 12 compliance requirements. First, administrators must install and maintain adequate network security controls. Second, proper security configurations must be set for all system components. Third, account data must be stored and protected. Fourth, strong cryptography methods must be used to protect cardholder data during transmission over open public networks. Fifth, systems and networks must be safeguarded systems from malicious software. Sixth, administrators must develop and maintain secure systems and software. Seventh, access to system components and cardholder data must be properly restricted based on business needs. Eighth, systems must be set up for secure identification and authentication of users accessing system components. Ninth, physical access to cardholder data must be restricted and secured. 10th, all access to system components and cardholder data must be logged and monitored. 11th, systems and network security must be tested regularly. And 12th, information security departments must be supported with organizational policies and response programs. Network security controls can include measures such as deploying a next-generation firewall or using a complex password for wireless access point administrator accounts that satisfy secure configuration requirements. Some examples to satisfy the cryptography requirement can include encrypting transmissions between headquarters and a branch office, and installing anti-malware software on endpoints that protects against malicious software. PCI DSS isn't a law, but many government regulations are based on it. Frameworks are collections of guidelines, best practices, or policies developed by third parties for organizations to use. The Center for Internet Security, or CIS, is a nonprofit that develops frameworks like the CIS, or Critical Security Control System, to mitigate internet-based cyber threats for the private sector. The National Institute of Standards and Technology, or NIST, is a U.S. Department of Commerce agency that advances standards for federal information systems, ensuring compliance with laws like the Cybersecurity Enhancement Act of 2014. It systematically addresses risks through 7 steps, including preparation, categorization, control selection, implementation, assessment, authorization, and monitoring. The International Organization for Standardization, or ISO, collaborates with member countries' standards bodies, while the International Electrotechnical Commission, or IEC, focuses on electrotechnology standards. Organizations implement security frameworks based on their needs. The CIS organizes recommended controls into 18 areas for private sector use. The CSA Cloud Metrics controls recommend for consumers and customers as well as providers, while its Enterprise Architecture Reference Guide aligns organizational goals with cloud security controls. These frameworks help organizations manage risk effectively. The ISO, or International Standards Organization, and IEC, or International Electrotechnical Commission, collaborate on global standards such as ISO IEC 27001, for example. These standards ensure consistency and security across industries worldwide. They guide public and private sector organizations in creating an Information Security Management System, or ISMS. Security Operations Center reports are developed by the American Institute of Certified Public Accountants in order to ensure that service entities securely handle users' financial information under the Statement on Standards for Attestation Engagements 18th Auditing Standard. SOC 1 focuses on financial reporting, while SOC 2 audits security controls. They offer point-in-time assessment and periodic assessment evaluations, respectively, to improve effectiveness. Next, let's look at configuration guides and platforms. A network connects at least 2 nodes in a system. Client access resources and servers share them while networking devices establish connectivity. Operating systems manage hardware, and platforms configure hardware and operating systems for specific roles like web servers, which respond to website requests. They also handle application servers, which host software, switches, which connects nodes and routers, and which links to networks. Secure baselines standardize scrutiny configurations to reduce vulnerability. They are established by defining controls and developed uniformly across the system. They are maintained through ongoing monitoring and updates. Configuration guides offer vendor-specific recommendations. Some of these include using boot integrity features, changing default credentials, enabling only necessary software, and restricting connectivity during installation. Some others include applying updates, enabling logging, using SSH over Telnet, and securing hardware physically. Physical network documentation includes physical network diagrams showing topology, floor plans mapping layouts, and rack diagrams that detail server rack equipment. Additional documentation includes wiring diagrams that show system connections and site survey reports. Logical documentation allows for the recording of configurations like logical network diagrams and baseline configurations. Standard naming conventions and IP schemas are also documented. IT assets refer to hardware or software components in an organization's infrastructure. IT asset management involves acquiring, operating, maintaining, and properly disposing of assets. This optimizes efficiency to enhance security and cut costs. This includes maintaining inventory, ensuring compliance, and securely disposing of outdated tech via sanitization or destruction in order to render devices unusable. In cloud computing, managing virtual assets like software as a service application requires tracking usage optimization for costs and also securing data. Data retention ensures compliance before disposal, and certification of disposal methods confirms that the processes were done properly and according to standard. IT change management structures modifies appropriate changes and updates to IT systems. It maintains the concept of the CIA triad. It involves planning, evaluating, approving, implementing, and reviewing changes to minimize disruptions and risks. For example, scheduling off-hours updates for implementation, evaluating and testing functionality, updating and reviewing documentation, and training users. Controls like allow-deny controls can mitigate risk, and managing legacy updates prevents vulnerabilities. Documentation, such as updated network diagram policies and version control, enhances security by tracking changes. Software automation can also streamline request approvals and scheduling and auditing, which helps to reduce errors and downtime. The System Development Lifecycle, or SDLC, outlines 7 phases for software development which can be used for updating security systems. First, planning. Second, requirement analysis. Third, design. Fourth, development. Fifth, integration. Sixth, implementation. And seventh, operation maintenance. The software SDLC focuses on software like building a database application, while the system SDLC includes broader system setup. Business continuity ensures functionality during disasters or incidents. It relies on disaster recovery to resume operations and incident response to handle security events. Plans include the business continuity plan for ongoing operations, the disaster recovery plan for post-disaster recovery, and the incident response plan for recognizing and addressing incidents continuously. Data classification categorizes data into 3 categories of unauthorized disclosure impact: low for limited effect, moderate for serious effect, and high for catastrophic effect. This classification helps guide governance and retention. Security policies prevent data loss. These include password policies with complexity and aging rules, acceptable use policies for resource use, bring your own device and remote access policies. They can also include onboarding and offboarding policies for access management, retention policies for archiving, and credential policies for authentication. Personnel policies can cover a wide range of office criteria. Some examples include background checks, job rotation, mandatory vacations, separation of duties, and social media use. Governance can be centralized or decentralized, with policies monitored and revised for new threats or requirements. Personnel training is crucial, as personnel are both a defense and a vulnerability. Non-IT personnel need security awareness training via gamified computer-based training or instructor-led sessions, often using phishing simulations to improve recognition. IT personnel receive technical training like role-based exercises, where they perform various roles or capture the flag drills, pitting red team attackers against blue team defenders, sometimes with purple teams enhancing defenses. Now let's look at security awareness practices. These efforts educate employees to recognize and respond to threats by improving awareness about policies and initiatives. Test phishing campaigns can be combined with training to check employee awareness of identifying fraudulent messages. Additional training can cover the importance of using strong passwords, properly securing removable media, and maintaining secure remote work behavior with company-approved VPNs. Awareness also improves recognition of unusual behavior. It also helps decrease the occurrence of risky actions like using unsecured Wi-Fi, forgetting to log out, or sharing information outside of a company server. User training and ongoing guidance turns employees into active defenders in the security system.